Hey y'all, it's me, Miss B, and today we're talking about the 10.1 through 10.3 review. Alright, so for this first one, all you're going to do is you are going to find the first 5 terms by just plugging in the values. So for ace of 1, I'm going to plug in 1 for n. So I have negative 1 squared times 2 factorial, which is 1 times 2 times 1, where 2 times 1 is the factorial, giving me that ace. I wrote too big. So we get that this is equal to 2. For ace of 2, negative 1 to the 2 plus 1 times 2 plus 1 factorial. So that's negative 1 to the 3rd times 3 factorial, negative 1 times 3 times 2 times 1, or 3 times 2 times 1 is factorial, so we get negative 6. Ace of 3 is negative 1 to the 3 plus 1 times 3 plus 1 factorial, so negative 1 to the 4th times 4 factorial gives me 1 times 4 times 3 times 2 times 1, which is 24. Then finally, ace of 4 is negative 1 to the 4 plus 1 times 4 factorial, or 4 plus 1 factorial, so I'm running out of space here. So that is negative 1 to the 5th times 5 factorial. So negative 1 times 5 factorial gives me negative 120. Okay. For this next one here, we have to know what R is, and that's the common difference. So we have the common ratio of a geometric sequence, so we need the general equation of a geometric sequence, which is this. So I have the first 5 terms, so I do ace of 1 equals 24 because it's given. Ace of 2 equals 24 times R to the n minus 1. So 24 times 1/3 is 8. Ace of 3, 24 times 1/3 to the 3 minus 1, so 24 to the 1 over 9 is 8 over 3. Ace of 4 is 24 times 1 over 3 to the 4 minus 1, which is 24 times 1 over 27, reduced to be 8 over 9. All right. Write a formula for the general term of each sequence, then use a formula to find the indicated term. Let's first determine if it's arithmetic or geometric. For adding, add 5, add 10, so it's not arithmetic. So we'll test if it's geometric. So I have times 2 to get 20, times 2 to get 40, so it's definitely geometric. So to find my general term, I need this equation. So ace of n equals my first term times my common difference, 2 to the n minus 1. So I need this for my answer. But it also asks for the 20th term. So ace of 20 equals 5 times 2 to the 20 minus 1. So 5 times 2 to the 19th. Plug it into your calculator. and get 621,440. And that is ace of 20. All right, you need both of those for your answer. All right, write a formula for the general term of each sequence, then use a formula to find the indicated term. Okay, for this one, I am subtracting 0.5, subtracting 0.5, subtracting 0.5. So I have an arithmetic. So to find the general term, I need this equation. So a sub n equals my first term minus my common difference, or plus my common difference, which is negative 0.5, and minus 1. Then I need to plug it in to find my 50th term. So ace of 50 equals 8 minus 0.5 times n minus 1. So 8 minus 0.5 times 49. 8 minus 24.5 is negative 16.5. That is ace of 50. All right, find the first sum of the first 10 terms. So sum 10 terms, and here's our sequence. Now we can continue sequence, but we are going to use the formula. So this is times 2, times 2, and times 2. So it's geometric. So we're going to use this summation formula. So S of 10 is equal to my first term times 1 minus my difference to the n over 10 minus 1. When I plug that into my calculator, I get negative 2728 over 3, which is about 9.3 repeating. All right, 6. Find the sum of the first 50 terms. For this one, I'm adding 20. So it's an arithmetic sequence, meaning I need to use this summation formula. So the sum of the first 50 terms. So this one is a little bit more gruesome. So we've got S of 50 equals 50 over 2. My first term is negative 11, but I don't know what ace of n is yet, so I need to find that. The way I'm going to find that is I'm going to find ace of n is equal to ace of 1 plus d times n minus 1. Ace of 1 is negative 11, d is 20, and n is 50. When you plug that into your calculator, you get 969. So I have S of 50 equals 25 times negative 11 plus 969. Plug that into a calculator and you get 23,950. All right, it's kind of in my way, so I'm going to shrink it down. All right, this next one, I'm just going to write out the first 4 terms and add them together. So plugging in 1, I have 1 plus 2 squared. Plugging in 2, 2 plus 2 squared. 3 plus 2 squared, and 4 plus 2 squared. I stop at 4 because this number is 4. So that's from 1 to 4. So I have 3 squared plus 4 squared plus 5 squared plus 6 squared, giving me 86 as my answer. 20 people live on the first floor of a building, 34 on the second, 48 on the third, and so on. What's the total number of people living in a building with 10 floors? Okay, so we are trying to find the sum of all of these. So it's from here, from 20 to 34, it's plus 14. 34 to 48, it's plus 14. So we have an arithmetic sum. So we're going to use this equation right here. So I need to first find ace of 10. So ace of 10 is going to be equal to ace of my first term plus my common difference times 10 minus 1. So that is 146. So that's my second term. So I'll just plug all of that into my equation. I'm going to move this over. So I have S of 10, sum of the first 10 terms is 10 over 2 times my first term plus my last term. When I plug that into my calculator, I have 5 times 166, which is 830, and we want to label that with people since we're talking about people in the building. All right, this next one here, I can add up the first 60 terms. It's just going to take me a while. So instead, I can use my geometric sum formula. So here's my geometric sum formula. So we have S of 60, because I have 60 terms, equals ace of 1, which to find ace of 1, I need to plug 1 into this equation. So I have 6 over 5 times to the 1, which is 6 over 5. So 6 over 5 times 1 minus r, which r in this case is 6 over 5. Those are different numbers there. To the n, which is 10 or 60, over 1 minus r. Okay, these two numbers are different. They end up the same, but they're coming from different places. Okay, so when you plug that into a calculator, you should get, grab my calculator here. Six over 5 times 1 minus 6 over 5 to the 60th over 1 minus 6 divided by 5. So we get 338,079.09, rounding to the nearest hundredth. Okay. All right, finally our last problem. Express the summation notation. Use I for the index. Okay, so I need to use the sum notation. Here it is. Okay, so we can find ace of n because we are adding 3 each time. We can use ace of n, and it's just going to be ace of 1 plus d times 1 minus n. So what we get is 3 plus 3 times 1 minus n. That's one way of doing it. Okay, so we can use this as our a sub n equation, or what we can do is we can say, okay, this is 3 times 1, then we have 3 times 2, then we have 3 times 3, then we have 3 times 4, all the way up to 3 times 32. And so my equation ends up being 3n. However, you probably are thinking, well, that's different than this equation. Let's go ahead and distribute this out. So we have 3 plus 3 minus 3n. Wait, what did I do wrong? This is n minus 1. Ha. Plus 3n minus 3. These cancel and I'm left with just 3n. So this whole thing is equal to 3n, which is what we get up here. So my equation is going to be I starts at 1 and goes up to 32 terms, and 3n is my equation. Okay, so we want to make sure we reduce these. All right, guys, good luck studying.